Good morning, everyone. This is Jairam here. So welcome to this session on data analytics demo and try. So basically, we are going to cover three key use cases today: the data quality insights, AutoML, and graph analytics. If you have any questions, please post it in Zoom Q&A at any time during the session. We have our panelists who will be more than happy to help you with your questions. One very important thing. So this is a demo and try session, which means you could also choose to try along with me, right? In case you wish to try, we have links and URLs available wherein you could just ask for it and one of our panelists will be sharing that with you, right? And in case you want to enjoy the demo and don't want to try, you are free to do that as well. This is me, Jairam Krishnamachar. So I'm part of the OCI Data Platform Solution Specialist team for APAC, right? More than 15 years of experience in data warehousing analytics, right? And what drives me is the fact that I'm able to articulate the power of data platform for advanced decision making to provide an advantage or an edge over the competition. So that keeps driving me, right? Now, before we start with the session, we would like to have a bit of an audience poll. Okay, there would be a couple of questions, an interesting one, and I would request one of the panelists to initiate the Zoom audience poll. I request all the participants to kindly participate in these two questions. You will have around 30 seconds. I hope you are able to see the audience poll. So take your time to read the question and see the options, and then please vote accordingly. Okay, 10 more seconds. Thank you for participating in the poll. We really appreciate the fact that you have participated, and then I think we even got our responses. Okay, nice to see a good participation here. So let's now begin with our session. So essentially, this session is about 3 demo and tries. The first one is around data quality insights. Second one is AutoML in Oracle Analytics Cloud. OAC stands for Oracle Analytics Cloud. And the third one is around graph analytics, again in Oracle Analytics Cloud, right? So let's start with the very first demo and try exercise. So just before we start, this is a slide that captures the end-to-end capabilities of Oracle Analytics Cloud, right from connecting to the data set till collaboration, various aspects related, okay, to analytics, data flows, managing the data, all of that is covered. But for this particular exercise, we are focusing on 3 main things. That's your interactive data transformation and cleansing, smart data profiling, and data enrichment. Okay, these are the 3 areas under data quality insights that we are going to explore and experience, right? Now, okay, so this slideware would be shared post the session. So in case you want to watch this in action, we have a YouTube video. Please watch it later at your at your convenience once the session is over. But for now, we are going to see it in action, right? So let me go into the URL, please. Okay, let me just refresh so that. Okay, so you would have got, okay, whoever wants to try would have got your credentials, okay? And also Along with the credentials, our panelists would have even shared the instruction manual, right? So you will be getting it in this shared folder, which says demo, try, hands-on instructions, right? Please download them and then use them to follow along. So almost all the steps that we are going to cover today is captured in this documentation, so that in case you miss out on something, you can always follow the document to move forward. Right. So this is the landing page of Oracle Analytics Cloud. So you could search for everything. It's like Google search for Oracle Analytics here. Okay, it could be workbook, connections, okay, machine learning models, okay, multiple things could be searched right from the home screen. On the left hand side, we call this the navigator. So it could be searching for workbooks, data sets, data flows, machine learning models, all of that could be done here, right? And we would be creating a lot of assets. So assets could be created by clicking on create button. It could be data sets, data flows, workbooks. We'll be creating a bunch of them today, right? So for this particular exercise, we are first going into the navigator, navigate to the data tab, right? So you will be only be using these three data sets. The other ones are just provided as reference, but these are the three data sets. The owner by default would be admin. So the very first thing I would request you to do is, right click on attrition prediction data and just create a duplicate. Okay. The moment you do that, a copy of this prediction data would get created. And once you have the copy, just left click on, sorry, not the left click, again, right click on the copy and just say open. Okay. So the moment you open, you are introduced to the data profiling, data enrichment, data preparation screen, as we can see here. In this, we are going to do a bunch of activities as part of our data quality, which is the data enrichment, data preparation, okay, and any quality checks. So the very first thing that we are going to do, select this column that says ID. This is an employee ID. By the way, this data set is an attrition data set. Basically, employee data, details about the employee, and and basically what we are trying to achieve is whether this employee is going to stay or leave. Okay, there are a whole lot of attributes related to the employee in this data set. So this is the employee ID. Since all of them are numbers, okay, the system has read it as a measure. So if you see hash here, it means it's a measure. So what we are going to do is we are first going to convert this into an attribute. Just click on the left hand side, it says treat as, and convert this to attribute. Right. So the moment we do that, the column gets updated to attribute. The next thing that we would see is first name and the last name, right? Ideally, we need the full name so that when we want to use it for any prediction, I have just one column for name. So what we are going to do is when I hover on the last name, okay, I can see a kebab menu. Okay, so the three dots is called the kebab menu. I click on that and I say concatenate. Okay, so the moment I do that, I get a new screen. So in this screen, I want to combine my first name with the last name. So I change this last name to first name here, right? And then I would like to give a meaningful name to this. I will just call it full name. Okay, so I have done that. I'm happy with this. Okay, I will let the delimiter as it is. I'm just combining the first name and last name to have a single name, which is full name. And then I will say add step. Right. The moment I add step, in a few seconds, you will see that the new column has been created for full name, which is basically combining the first and the last name. The next interesting thing is SSN. So SSN means social security number. The system has been able to identify that it could be potentially PII data or confidential data, right? So it is suggesting, okay, a machine learning model has seen this data set and it is suggesting that I may want to obfuscate this SSN so that I'm not sharing some personal data with others. So I just click on it. Okay, I use the machine learning driven recommendation to click on SSN so that all of it gets obfuscated. The next step that we will do is with respect to age. Now, if you see so far, all of the columns have a against them, which means it's an attribute. Now, this has hash, which means it's a measure, right? Now, when we are using a measure column for any prediction per se, which is going to be our next exercise, we would like to have some kind of binning so that I get much aggregated data for better prediction. So what I'm going to do here is I select this column. Again, I click on the kebab menu and then say bin, right? The moment I do that, a binning option gets created for me. I will just give it a meaningful name. I call it age bins, right? By default, I get 4 bins. I only want 3. So I will reduce it to 3. Then I have some age groups. Okay, if you see, the system has automatically created age groups based on the data spread. So I'm going to give them some names for the bins, right? So I will start typing as first one would be young adults, less than 33. Between 33 to 45, it would be adults. And then the last part would be, I would be calling it as seniors. Okay, so the moment I do, I just need to add step like last time. Okay, so you will see that the age bins has been created. So the age bin step is done. The next thing I would like to do as part of the entire data preparation, data quality insight, is to look at this date of joining column, right? If you see, it's a date column, but it is captured as an attribute. So when I select this, the system is suggesting me maybe this column may not have been captured correctly. There may be some pre-process that may have to be done, okay, so that it gets converted into the right format. I will just use the recommendation. I just click on convert detected format to date. I select this option. The moment it gets changed to date, the system is now providing me a whole lot of recommendations which I could use to augment my date column further. Let's say I want to extract years or age of the employee during the stint in this organization. I could do multiple things. So for that purpose, what I'm going to do is I will select this date of joining again. So for whatever changes you may want to do, you click on the kebab menu on the second part of the screen, okay, and then say extract age, right, in years basically. So what I'm planning to achieve here is that I want to understand how long has this employee been in this particular organization, right? So I will say select age. I'm not interested in months and days. I'm just interested in years. Okay. The moment I apply that, I'm getting a new column called date of joining. Column name needs to be fixed, right? So what I'm going to do is, again, kebab menu, rename the column to, let's say, years in the current company. Okay, I will say this, I will say enter, so that that particular column gets updated. Now, if you see, we did a whole lot of steps so far, and every single step is getting tracked, as part of my data profiling, data quality insight activity, right? So this basically allows the user that in future, if you want to edit something, if you want to remove the step, okay, you will be able to do so. And also you will know what all steps were done, okay, so that I know how I use this data to prepare it for the analysis. Okay, so we are done. And in case, let us say you want to explore a few more things, right? What else could be done? You could click on any column. Okay, right now I'm not going to do anything, but I'm just going to show, right? I can click on any column and I can just say edit. So the moment I do that, I get a Excel formula like screen where I have a whole lot of formulas that I could use to perform any kind of further augmentation of data, okay, which could be some preparation or something to do with mathematical operation, string operation, aggregation, a whole lot of Excel like formulas would be available for you to use. Okay, for this exercise we will not be doing any of that, right? And another thing which is also mentioned in the documentation, so typically this is what the profile of the column looks like. If you see, it's basically the frequency distribution of the values. Okay, so if you hover on it, you will even come to know what is the total number of columns, okay, that is present in the particular column, total number or percentage of values. So it will allow you to understand which values are higher in number versus the ones that are not high, right? And furthermore, you could even apply a filter. Let's say there is some red part in the last name. Okay, if you want to understand, if there is any missing value or invalid data, you could do that as well. So for now, we will not do that, right? We'll just leave it as it is, right? In fact, I clicked on a particular column and it got filtered as well, right? So let me clear the filters. So now we are done with this exercise, a fairly simple one and an interesting one to warm you up for the next couple of exercises. Okay, I'm happy with it. I will just click on save, right? Don't do anything else, just click on save dataset. Right? The moment you do that, a busy bar was initiated and then the whole data got saved. Okay, so we now conclude the first exercise. Let me now go back to the slide where. So we just concluded it. And a very similar video of what we just did is also available on YouTube. Just to reiterate, you could always watch it once this slideware is shared. Moving on. So before we move on to the second exercise, this is a very interesting survey that we did, which is around decision dilemma, right? A sneak peek into it is what is given here. So 89% of JPAC people say that they have inability in making decisions, which is causing impact for quality of their life, right? It could be spikes in anxiety, it could be missed opportunities, unnecessary spending, crushed confidence, okay, and decision paralysis, right? So more than 30% for each and every line item is mentioned by the survey users, right? So what it essentially says is that you would need a data platform, a decision support system to be able to address day-to-day decision making, right? And that is what we are trying to address in today's session. Moving on. So we are now going into the second try, which is OAC AutoML. Now this is a process, unlike the last one where we selected multiple columns and made some changes. This is a process. Now, what is this process all about, right? The very first thing is to identify the training data. Okay, again, we are going to use attrition data, which is the attrition training data to train the model. Now, what is that we are going to train it on? We would like the model to predict whether a particular employee is going to stay or leave, right? Now, depending upon the column selection, okay, once we add the data into the flow, we will have to identify which column has that information of attrition. And depending upon that, when we add the AutoML component, it automatically suggests whether it's going to be a classification model or a regression model, right? So regression is only considered for numeric columns, and anything categorical would fall into the classification. We are going to see that in action shortly. Once the AutoML component is selected, right, then the whole training life cycle gets initiated. It does the algorithm selection for you. It does adaptive sampling for you, wherein the lesser values get upsampled and more number of values get downsampled so that the balance of the data set is maintained. Then it does auto feature selection for you. It differentiates between what are those important factors. Let us say distance from home, or okay, years spent in the company, or age, right? If these are key features that get highlighted, let's say if there is something else which may not be important, let's say first name, last name may not be important, so it could consider to be kept out of the model selection, right? So it does the feature selection for you. Then it tunes the model, that means the skewness is addressed, and then the model will be available for you to apply for a new prediction data set, right? So these are the steps that we will follow. And for your information, all these steps are under the hood, right? As a user, you just have to select the component and the model will do the rest of the things for you. And hence it is called the AutoML model. Now, if you see, in this try, in the last try, we use only Oracle Analytics Cloud, but for this try, we need autonomous database because the AutoML engine is in the autonomous database layer. Autonomous database is nothing but our Oracle database, which is significantly automated for a lot of DB activities. So we are going to use this database, which is data from this database, which is already made available to you, which we are going to see in a moment, and we are going to use the AutoML from OAC, push it to the AutoML engine of autonomous, and then the output will be returned back to OAC front end, right? So that is what we are going to do that. And again, you could we have a video for this, and you can always watch it later. Now going to the interface again. This is the OAC interface. Let me just make it bigger for a better viewing purpose. So what I will do, I have anyway saved. Okay, I will go back here, right? So the next thing I will do is I need to prepare a training model, right? So for this purpose, I'm going to navigate to this create option, and I will click on create. So I need to create a data flow to train the model. So I'm going to select data flow. So once I select the data flow, you will be presented with all the data sets that are available for you to see. And here, what you need to do is you need to select attrition training underscore data. So that is the data set, that is the training data set. Okay, kindly select this, and the moment you select, the add option gets highlighted, you add it into the flow. Okay, so the moment I add it into the flow, I see various columns related to the particular attrition data set. Multiple attributes of employees are visible to me here. And then the column I want to train my model on is on attrition. Basically, this is the past data of people staying or leaving the company, right? Now, what I'm going to do, I'm going to use this plus option, okay, which says add step, to actually select AutoML, right? The process itself, okay, or the object itself is called AutoML. I select that. The moment I select, I am just given one decision to make. Okay, I am significantly insulated from complex decision making in terms of what model to choose, what algorithm to choose. That is all auto. All I need to tell the system is this is the target column on which I need to train the model. So I select this column, which is basically my attrition. So the moment I select attrition, the object understood that it's going to be a classification model. And one other important factor for any machine learning model is what we call as model ranking metric. So if you click on this, okay, you get multiple metrics that could be used for ranking your models, because there are multiple algorithms that are going to be used, and the best algorithm would be finalized. So let's say if it's a balanced data, we'll go with accuracy. And when you hover on each of these metric, you will get the explanation, which gives you a good understanding of what this parameter is all about, or the metric is all about. Now, since it is an unbalanced data, because the number of people who are going to stay will be higher than the number of people who may leave, so I'm going to use balanced accuracy as my modeling metric. Now, just to give you an example of how automatically the system understands whether it is classification or regression, okay, if you want, you please try changing this to, let's say, age, which is basically my numeric column, and suddenly it has become regression, and by default it is taking R square as the model ranking metric. But we are not interested in that now. We'll go back to attrition, okay, and then we'll go with the balanced accuracy. Now the next step is to save this model, right? Now the point here is we need to give a meaningful name and then run the flow here. But for now, okay, since a whole lot of people have asked us to give the environment and try it themselves, and since this is a machine learning building process, it is in real life done by 1 or 2 power users and not concurrently. So for the purpose of this exercise, we have restricted the access levels to the user so that they will not be able to run. And if you try running, you may get an error. So please don't run this. What we have done is, so this model has been already run for you. That is this data flow, and model has been made available for you. So what we are going to do, so this is how you will, in real life would actually execute the model. But for now, let's assume this model has been already executed, this data flow, and we have the model ready. Let's just navigate to that model to understand how that particular model looks like, right? I'm going to go back. I will not save any no changes to the data flow. Okay, just say don't save. And then by default, you may be redirected to the data tab. Again, click on the navigator option and then go to machine learning or navigate to machine learning. Here you see that there is attrition prediction AutoML model already made available to you. Okay, so what you need to do is just right click and say inspect, so that you know what is this ML model all about. So some general information: it was created by admin. There is a database connection to autonomous database. Okay, it's an external model. It means it is not created within Oracle Analytics Cloud. It is being picked up from autonomous and made available in OSC. So that is our deep integration with autonomous, and the name of the model is given. The next tab is around details. So this is an important tab, right? So it gives you model info. So classification was chosen as the class that we saw, and algorithm was neural network. So multiple algorithms were run, and it was found that neural network is the best algorithm of the lot. So that has been finalized. Now here's the owner who ran it for you. Then there are input columns. So this is basically what were considered for feature selection. Okay, so the input columns are available. Then output columns, some are basically some are mandatory and some are optional. So you may see only a few of them when we are going to apply it on a new data set, which we are actually going to do in a moment. So all that information is available here, output columns. And then for the model itself, if there are any hyperparameters, right? Okay, number of iterations, then random seed use, those kind of typical ML parameters for neural network are also mentioned, so that you know how this model has been run. And then whenever we run such a model, a whole lot of machine learning views in our autonomous get created, and those details are also available here. Okay, so it could be the network weights, it could be the scoring cost matrix, it could be normalization and missing value handling, all those different things that are required for the machine learning model to be developed and made available. So those are mentioned here. This is the name of the view, and this is the corresponding description, right? At any point, if you have the right levels of access, you could connect and then in fact view what is in each of these particular views that are created. Okay, for now, this for information purpose, we will close this pop-up. Now that we have trained that model, right, and we actually want to run this is something that we will do. So again, what we'll do is, okay, in the same screen on the right hand side, you will see this create option. Click on create and click on data flow. So what we are supposed to do, we have already trained an AutoML model. Now we want to apply this AutoML model on our prediction data set that we just prepared in our earlier exercise, so that I see an output. So what I'm going to do, I'm going to select this attrition prediction underscore data hyphen copy. Okay, ensure that you select the right data set. So this is the data set that we used for preparing in the last step. Click on add. Okay, so you get all these different columns. If you remember, we had added full name, we had added, we had obfuscated SSN, we had created age bin, so all that is available. And then we will say apply model. So last time we used to train, now we need to apply this model. What we have done is we have tried to keep the experience as consistent as possible, so that the training step, application step are straightforward. Okay, you don't have to break your head for it, right? So again, click on apply model, and this particular attrition prediction AutoML that we just saw is available for you to apply. Select this model and say okay. The moment I do that, right, I get to see what are the output columns that I will get, okay, in the output data set. I can scroll down, and there are some lift and gain that if I require, I can create. But for this exercise, we'll leave them as default. We'll not make any changes to that. Okay, it is more for understanding how good the model quality was. But for now, we will not use it, because this was created by the AutoML functionality. And then here, if you see, there are two columns that were used for training. Okay, as in the column names look slightly different than the columns names that we gave for preparation. This was done purposefully so that when we are using AutoML, all the columns used for training need to be present in the prediction dataset. So if they are not, the system specifically asks to ensure that they are mapped. So what we are going to do, we are going to select the column that was used to identify years in the company. So we mentioned years in the current company, so that is the age in the company, and then we also created an age bin. Okay, basically the young adults, or the seniors one. So we select that. So now you know why we created the data preparation and looked at the quality, right? So if you have a model that was created using a particular data set, those columns need to be available. We prepared them and we are now mapping them, right? The next thing that we will do is this particular flow will create an output data set, which includes prediction and prediction probability among others. So we want to save it into a data set, right? I click on it and I say save data. When you do that, right, what happens is that I need to give a meaningful name. So what I'm going to do is I will say attrition prediction data. Okay, don't give any space. Okay, since it is going to be a table that is created in the database, so avoid any space or any special character. Okay, and then please ensure that you append your user ID to it. Okay, underscore works, but you could even have, let's say, I will just say user one, right? Depending upon what was the user ID you received, you please append it. Otherwise, right, when the table gets created in the database, everyone will see the same table and then there may be a conflict, right? Once you give this name, please copy this and ensure even the table name is also the same. So what is happening here is that two data sets will get created. One is the table itself, okay, that is in the autonomous database. So this is the connection, the autonomous database. This particular cloud icon with the house is the icon for autonomous database connectivity. So this table is getting created and a corresponding data set of the same column, same value will be available in Oracle Analytics Cloud as well, okay, in just single flow. So that is what we are trying to do. The name of the data set and the table ideally should be the same. So we are doing that. And then we are going to run this data flow. Okay, this time we will actually run it. So please click on the play option on top right corner. And then, so you would have copied the data set, just copy paste it so that there's the meaningful name for the data flow, and just say DF. DF stands for data flow. Okay, so idea is when these objects are getting created, at a later stage, it becomes easy for me to search and identify what was the flow, what was the data set that I had created for various activities, right? So I'm going to create data flow and I'm going to say okay. Now this particular flow is triggered. Okay, so just give it a few seconds. It takes anywhere between 20-25 seconds to run. Now what is happening in the backend, okay, while the flow is running, is what we have taken as a screenshot for your better understanding. A model got initialized, algorithm got selected, there was an adaptive sampling to balance the data, feature selection happened, model tuning is happening, and underlying these are the different models that were considered, right? Linear vector machine, support vector machine, that is linear, then generalized linear model, naive Bayes, neural network, okay, again Gaussian, SVM, all these were considered, and even the feature impact were predicted. So this is for a different model, but this is the backend activity that is happening, that is completely insulated for you. And then what happens is the different models along with the model name and their balanced accuracy get depicted, and depending upon what data set and what ML we used, this model and this balanced accuracy value may vary, and the system picks up the one with the best numbers here, because we chose our ranking metric as balanced accuracy. Whichever had the best ranking. In this case, in our case, it was neural network that has been considered as the option. Now going back to our flow here, I think the flow has been completed. Okay, we should now have the new data set. So what I'm going to do, I'm going to go back, and by default, I may come into my ML screen. So again, click on the navigator and traverse to the data, right? So you would have created this new data set, that is attrition prediction data user 1. For you, it could be user 15, user 20, whatever the number is, okay? So that is the one you need to select. This time it is not right click, it is left click. Just click on it. The moment you do that, this particular data set, okay, will open in a workbook mode. Okay, that is the difference between opening it via right click versus opening it via left click. Left click automatically opens the data in a workbook mode, whereas the right click opens it to allow you to prepare the data and save for further activities, right? So what we are going to do, we are not going to create any dashboards per se. We are just going to observe what has been the prediction, and we also are going to apply filters so that only the high probable ones are filtered. So what I'm going to do now, I'm going to select the prediction. This has the information around, this is the predicted attrition, by the way, information around whether the employee is going to stay or not. Then I'm going to hit my control button and select prediction probability, and then the full name that we just created earlier, right? Again, keep the control button pressed and select so that I get multi-select. Then right click and say pick visualization. So I want to have control of what visualization I would like to see. I click pick visualization, and in this case, okay, select table, okay, as the visual, right? Just to keep it really simple. So what happens now is I get the prediction, I get full name, prediction probability. So I can just move around that table as well. I want to have full name as the first column. I can do that as well. And I have various predictions along with the probability. Now I want only those probabilities which are 70% and above, right? I don't want all of them, okay? So what I do, just again, in the same panel, that is the data panel, you just click outside, don't click on any column, so that the multi-selection is removed, and then select prediction probability and add it to filters. Okay, so it gives you an option to start with the minimum value. Okay, in this case, we want anything above 0.7. So we only have starting, ending, I want the maximum. So I can just say 0.7. Okay, because it's basically 70% and it is 0.7. And once I do, just click on enter so that a filter gets applied on the data. And then you see that the filter has been applied, and we know who are the ones who are going to stay versus not stay. And further, you could just even sort the data between A to Z so that I group them. So these are the 3 people who are very high likely to leave, and the rest are more likely to stay. And this would open up a whole lot of use cases that you could try. Let's say you want to see who are those employees who are high performers who are very likely to leave, okay? And those are the people you want to hold on to, so that you may want to have some intervention so that they can be retained. So many such things could be done, and various aspects of, for example, there could be performance rating that could be available here, which you may want to add and see, if they are highly rated, employees. Okay, so now one additional bonus step I would like to show, again, it's not captured in the manual. So in case you want to understand how the prediction has functioned within OIC itself, you can see what are the important factors that was considered for a prediction, right? Just right click on prediction and you can just say explain this to me, and in a few seconds a whole lot of machine learning model would get triggered, which actually gives you an explainability of how the model, what attributes were used to predict. There are around 200 columns. So here is the key driver for prediction. Some of the key drivers are essentially overtime and job role, right? Among others. So for example, people who were made to work overtime, okay, are more likely to leave the company as against the one which did not have overtime. And similarly, the sales and laboratory technicians are more likely to leave, right? So this way, depending upon what model, what data was used, whole lot of predictions could come in, right? And one more small other thing that you could even try, of course, this is a bonus step. You could even look at some segments that may have been created, right? So for example, there is a segment where the prediction is they're likely to stay, okay, around 114 rows. Performance rating is not high, okay, and there is no overtime. And so you even could get multiple such segments to understand the characteristics of employees who are going to stay versus not stay. So this is a bonus step. I thought I will cover this. Okay. So this brings us to the end of the second exercise. I hope you enjoyed, applying the model and seeing the outcome of it. Now let's shift to the next one. Okay, let me go to the next one. And before the next one, here is another sneak peek into our decision dilemma, right? So 61% admit they face a decision dilemma, 33% don't know what data to trust, and then around 70% have more or less given up on decision making because the volume was too high. So this is where, having an underlying aggregation layer like autonomous DB, and then insulating the users from all the complexities so that they are only looking at the relevant data and providing them tools to quickly run different models would significantly address the decision dilemma. Now on these lines, let's look at another very interesting, powerful technology, that is graph analytics, which could help you further to address the decision dilemma you come across. Now when we talk of graph analytics within Oracle Analytics Cloud, there are 4 key use cases that you could try. The first one is clustering. Clustering is basically, what are the components in a cluster that are connected, okay, versus unconnected. So some of the examples would be, let's say, customer segmentation. What are the characteristics of a customer behavior, so that I have clusters and I can, promote my products accordingly. So similarly, the way we saw our explainability on our HR data, so you saw there were some specific segments that got created, so you could have clustering using graph as well. Product recommendation, right? Again, you can see which products are selling where, what is the quantity, volume, and then you could have clusters of those products. You could even look at how different demographics, socio-economic parameters are impacting the social media behavior of the user, and accordingly plan your customer strategy, right? These are some examples for clustering. The next is node ranking. Node ranking is all about in a cluster or in a network, okay? So graph is all around networks. In a network, which are the most important, nodes, okay? So basically the node could be a person who is a social media influencer, or it could be a page in a website which is mostly visited by users, okay, on a portal. Or let's say it's a transportation or logistics scenario. It could be even a warehouse or a train station, which tells this is the most critical station or a warehouse in my whole network. So I need to ensure they are well connected, they are well taken care of, right? So it could be those use cases. Basically, importance of nodes in a graph for node ranking. Talking of subgraph, this is again a very interesting use case. It tells you if you want to reach out to some person, okay, in a network, how many people that you need to touch before you finally end up meeting that person, right? That could be one example. Basically, how many intermediate points are there between point A and point B is what we try to understand in subgraph. So one very good use case is anti-money laundering. So let us say there is a user or there's a bank account holder who is moving his or her money into multiple different accounts, and finally it comes back. You could see how many accounts that money was transferred into, or transferred out, so that these are connected loops, right? Similarly, you could say, let's say I have a train station and I want to go from train station A to train station C. There could be a B in between. So to know whether it is just B or whether other stations are also there, you could try this subgraph. And also components required. So if let us say there's a very, very important component that may not be available, you could see if this is not available, how many other components may get impacted in the entire network, right? So you could do such use cases. Shortest path is the fourth one, which is basically tells you between two vertices, which is the shortest distance, like logistics optimization, or if you want to ensure you have a shopping e-commerce website and want to ensure the easiest path between product selection and checkout, you could use that use case. Or even optimizing your new stores in a location so that they are not very close to each other and optimally placed, you could try this option, right? So this is basically the example. Now let's just jump into the actual exercise here. All of it is going to be made available as a project, which I'm going to show, but we are going to use cluster to do it from scratch. Okay, the clustering in graph. Again, the tools used would be Autonomous Database and Oracle Analytics Cloud. Please remember, for both AutoML as well as graph, Autonomous Database is almost mandatory, without which the graph capabilities within OIC may not work. Okay, that is the integration that we have done. Okay, now let's again go back to our Oracle Analytics Cloud. So if you have done this and you want
if I may, just wanted to make sure you are check on time, because we've got about 10 minutes left.
Yes,
so just to let you know.
Yes, thanks, Alan. Yes, 6 to 7 more minutes we should be done. Yes. Okay. Now please save this. Okay. And what I'm going to do here is I'm just going to give it a name, AutoML demo. If you would like to save, okay, just save this so that we could move on to the next one. So I'll be a little fast because it's a fairly straightforward one, and the documentation is already made available. Go back again, like last time. What we are going to do is select this graph demo dataset, that is the autonomous database dataset. Okay, just observe the cloud icon, right click and make a copy. Right, just create a duplicate so that you get the copy here. So once you have the copy, go to create data flow. Okay, select the copy that you just created, add it into the flow. Right. So this is a Indian railway station data set. For your information, we are trying to see which stations are connected to which other stations and which are not connected. So that is our use case here. So the source names or destination names are available. Okay, they're not exhaustive train stations. It's a subset of train stations for your information. We have other information like time between the stations required on an average speed to move from one station to another station, or the train speed between the two stations, number of people that typically use on an average, and distance between that. We have other key information as well. So we are going to add the graph model here. So when you select plus, you please observe that graph analytics is highlighted here. If it is a non-autonomous database data, this will be disabled. So select this option and select clustering, say OK. And here, what I would do is I would select the source name, okay, and then I would select the destination name. Now observe, my output column will be a cluster ID. Basically, it tells me how many clusters are there in this group, and then the node vertex, as in it could be the source station from which all the clusters are getting created, right? So that is the center point of the cluster, basically my node vertex. Now what I'm going to do, just ignore this warning, okay? Don't worry about that. Then I'm going to save this data. Because I'm going to get output columns, I need to save it into a new data set. I click and I save this data. Okay, just remember, like last time, we need to give a meaningful name. It is graph, I will just call it graph cluster user 1. Okay, I will copy this, again paste it into the table name. They need to be same. And here, please remember, cluster ID by default, it's a numeric value and is going to be treated as measure, but we want it as an attribute. Just change it to attribute. Okay, then run and save and run the flow. Okay, I'm going to paste this and say okay. Now again, 15 to 15 seconds, not more than that, you should be able to get the output column. Okay, I request everyone to try, since what's happening in the backend, okay, is that particular table what is in the autonomous is brought. This the OIC is applying that graph model to create the cluster, and then it is running the flow, right? So all of taking the model from OIC interface, pushing it to the autonomous layer, preparing the output, and then pushing it back to OIC layer is what's happening. So it took not more than 10 seconds. My data flow is done. Okay, so like last time, I will go back. I have created a new graph cluster. like last time, I will do a left click. Okay, so here the output will just contain one cluster ID and one node column as 2 columns, right? To see how many clusters got created, I can just drag and drop this cluster, and then I can see a whole lot of clusters. Basically 5 clusters have been created. Okay, now I need to combine this information with my train station information so that I get some meaningful graphs out of it. So what I'm going to do, I click on this data tab, or there are 2 ways, but let me show you the easier way. I think this is a little more complex way. So I'll use this plus option and say add data, right? So I'm going to bring back my graph copy. I can just search it here, graph, and I would like to say take this copy, graph demo dataset copy, add to workbook. And then now by default, if you see a horizontal line in between, it means they may not be joined. So this is where I go to the data tab and I hover on these 2 tables, which I see 0, which means there is 0 connection or columns related to each other. I select this, I say add another match, and then I select the source name from the graph demo dataset, and from the graph cluster dataset, I select the node vertex and say okay. This means this particular these two datasets are now connected via the node vertex. Okay, that's what this means. I'll come back to my visualize tab. Here, I need to create the right graph to see this information and make sense of it easily. So what I'm going to do, I'm going to navigate to the visualization tab here on the left hand side. And when I scroll down, I see that there is a network 10K plugin. This is the right plugin that needs to be used. This is a custom plugin. In the hands-on manual, you will get the link to download to your own instance, but in this instance, it's already made available. I just drag and drop it here. And then I come back to my data tab to select the right columns into this, right? I expand this. So I need to select source and destination. I can select link length if required, that I can decide what I need to use, and I can even have some color. So what I'm going to do, I need to have my source and destination here, which is my source name, and my destination name, which is destiny. The moment I do that, you'll start seeing a graph getting plotted and created, right? It takes a few seconds to get set up. You see that this is loading happening. Okay, so the 5 clusters are being formed as we see. Then just to differentiate between clusters, I can add this cluster ID into my source, which is basically my node color. Okay, so the moment I do that, there are multiple colors that got created based on the different clusters that were formed. Okay, so it takes a few seconds to get set up like last time, because there's a whole lot of visual information that is getting created. And I can further enhance this by let's say I want to see the distance between 2 stations, right? I can just drag and drop distance into my link length. Okay, so that I get the distance information, right? So if required, I can hover. Okay, let it get loaded completely, and I could hover on it. So if I hover on it, okay, so I see that now I'm just taking up something easy to read. So source is Rangpura. These are Indian names. Okay, don't worry about the names themselves. And the distance is 400. So this is how the networks are available for you. And this seems to be the biggest cluster among the 5. This is 1, 2, 3, 4, and 5th one, right? These are the 5 clusters that are created. Now let's say I want to understand for a given train station, what are the other stations connected to it? All I need to do is I drag and drop the source name into the filter and start typing Lucknow, right? L-U-C-K. I've just used a simple destination name for you to follow, and select Lucknow Junction. The moment I do, I can just click outside so that I see the full screen. I can expand this. Now I know this is my junction, and these are all the various train stations that are connected to this station from, and also the corresponding distance. Let's say the Varanasi, the oldest city in the world, 560 kilometers from this Lucknow junction. This way, there are a whole lot of use cases that you could try and use the graph analytics. We're almost coming to the end of it. Just before that, if you want to save, okay, you can just click on save option, and then you can just name it as graph demo and then save, right? What we have also done is just to give you a sense of how the other projects of graph would look like node ranking, shortest path. A particular workbook is made available. For viewing that, click on the navigator again, go to catalog, and then you will see something called under shared folders. That is, okay, from my folder, navigate to shared folder. You will see graph demos as one of the shared folder. Select that, and you have this graph workbook that has been created, right? So this similar data set, okay, and then a whole lot of projects are there, like basically 4 of them: the shortest path, cluster that we just did, node ranking, and subgraph. So we have just given you a view access to this. You can just click on each one of them to see how you could actually have different graphs come up for you. So this brings us to the closure of the third exercise. Now coming back to our to the slide where we have just completed this graph analytics use case. Again, a sneak peek into another interesting statistic. So people in JPAC believe a company that uses technology to make data-driven decisions is more likely to be successful, more secure, more investors, and attract more talent. Again, we have shown you those technologies which could help you achieve this, right? Now, moving on, since we have come to the end of the session, and just a couple of more slides before we close, we would like to have an audience poll. I request the panelists to initiate. I think it has been initiated. So which area are you most interested, based on the exercise that we did and the demo that we saw, whether it's AutoML, whether it is graph, whether it is both auto and graph, or you would want to think further. So please feel free to provide your valued feedback via this poll. And again, another 5-10 seconds, we should be able to close this. Okay, so I think most of you would have given the poll. We are just 2 minutes to the top of the hour. So before we just end, if you have any open questions, please feel free to put them in Q&A. Our panelists would answer, right? So that we will just keep the session for a few more minutes, so that if you have any open questions, we could address them. And we also have made some of the additional resources. Okay, for example, if you want to try some more hands-on, we have a concept called Live Labs with Oracle, and we have made 3 interesting labs available for you. One around focuses on preparation, one focuses on AutoML, one focuses on graph, among others. So you could actually try it at your leisure. Then we also have additional resources. For example, if you want to know more about our analytics platform capability, or more demos you want to see from a public interface, you could do that. If you want to understand what use cases that could be done using graph database, again, that information is made available. There are free courses in Udemy you could try, and then a few blogs. Okay, again, this whole slide or the deck would be shared, and you could click them to find